Good morning, friends. We are discussing now processing of n jobs through two machines. That is, number of jobs given will be n. So they have to get processed on the two machines. If the machines are given named as A and B, first the job should be getting processed on machine A, then it has to get processed on machine B. In the earlier cases, the number of jobs taken were maximum of 5. Now, 7 jobs to be performed on the two machines AB in the order AB only. That is, whatever is the job taken first, it has to enter machine A. From machine A, it has to enter machine B. So the processing times given in the table, maybe in minutes or hours, accordingly will take. So determine the sequence of these 7 jobs that will minimize the total elapsed time. Also find the total elapsed uh, uh, time and idle time on machines A and B. So first you have to search for the minimum processing time. So in the given table, the least processing time is 1 here. That is for second machine, that is machine B for job 6. Since it is for second machine B, so this job 6 to be placed in the ending of the sequence. So 6 will be placed at the ending of the sequence. If it is on first machine A, it would have been placed in the beginning of the sequence here. The reduced set. Okay, in the next iteration, we are eliminating job number 6 because its position is fixed now. So we have left out with 1, 2, 3, 4, 5 and 7. Now we'll see the next minimum processing time. So that is 3 here. So there is a clash. So it is on machine B as well as on machine A. So there are two equal minimal values. That is 3 hours for job 1 on machine A and a processing time of 3 hours for job 7. Okay, so here 3 is this 3 is on second machine. So that is machine B. So the job to be sequenced in the last. So using Johnson's algorithm. So if it is for second machine, the job should be sequenced last. If it is for first machine, it has to be sequenced in the beginning. So now job 1 so is also having the same 3 hours. So it is for first machine. So job 1 will be sequenced in the beginning, 7 to be sequenced in the end. So already 6 is in the last position. We are placing 7 next to it in the last. 1 is placed in the beginning of the sequence. Now the reduced set of processing times. Now 1, 7 and 6 are not considered in the next iterations. We have left with 2, 3, 4, 5 with the processing times here. So the next processing time minimum is 6. Now it is same 6 on both the machines A and B for the same job 4. So either 4 will be kept in the beginning of the sequence or 4 will be kept in the ending of the sequence. So it is for the same job for both machine, first machine and second machine. So if it is considered as for the first machine, keep 4 in the beginning. Or if this 6 to be considered, it is for second machine, that is B. So job 4 will be either it is placed in the ending of the sequence, either like this or like this. Now the reduced set of processing times are with 2, 3 and 5. So we have now 3 equal minimal values. So that is 10. The same 10 is occurring at 3 different places for all these jobs, 2, 3 and 5. So this 10 for job 5, it is on first machine. So if it is on first machine, so the job should be sequenced in the beginning. So 5 mandatorily will be kept in the beginning of the sequence here. That is, if we consider this sequencing. If I consider this sequencing, 5 will occupy next to 1. If we consider this, 5 will occupy after 1 and 4. So that is 1, 4, 5. Here 1, 5. Then in the end I have 7 and 6. Now using the repeated steps, so we have other 2 jobs 3 and 2 that will be finally sequenced like this. This or this. Now calculation of total elapsed time on both machine A and B under their idle times will be done as usual. So the job sequencing has taken the order 1, 4, 5, 3, 2, 7, 6. 1, 4, 5, 3, 2, 7, 6. If this sequencing is considered, then the table will be formulated as we did for this first sequencing. So 1, 4, 5, 3, 2, 7, 6. 1, 4, 5, 3, 2, 7, 6. So job 1 will enter machine A first. Then from machine A it enters machine B. From machine B it has to so it will come out of the machine B. So then idle time machine A and machine B. So job 1, it enters machine A on 0th hour, getting processed there. Job 1 for 3 hours on machine A. So it comes out of machine A on the end of 3rd hour. So then it enters machine B at the end of 3rd hour, getting processed there for 8 hours. So 3 plus 8, 11. So machine A is kept idle for 0 hour. But for this job number 1, machine B is kept idle for the first 3 hours. So writing 0 and 3. So like this, we are filling the entire table, and it is found that the total processing time taken is 67 hours. And after all the jobs are over, so all the jobs getting completed on machine A on 66th hour. But I can declare that the project is over at the end of 67th hour. So after 66 hours, so machine A is having no job. So for the next 1 hour, it is kept idle. So machine B, it is 0. So now total project completion time is 67 hours. The summation of all this is 1. So machine A is kept idle time for 1 hour, and machine B, summation of this is 17 hours. Thank you.